And I think networking automation and really automation in general, it's not just a technical problem, it's a cultural problem as well. You need to make some certain cultural shifts and philosophical shifts before you're really successful there. What have you seen in organizations that have been successful with some level of networking automation? What are those cultural shifts, and can you describe them?
Yeah, that's a good question. First of all, I'm going to recount a conversation I had at lunchtime. So somewhere out here where some gentlemen I was speaking to at lunchtime about this subject. And part of the conversation was a very familiar story about how their organization, their team, went through an evolution to bring the development team and the operations team together. And the reasons they had to do so is that, frankly, they could not have achieved the business goals that they were given if they hadn't striven for automation and they hadn't reorganized what they're doing. In that conversation, I was asking them whether they'd been bringing the network people into the conversation. And by and large, they hadn't. Which is to say, they were focusing on their ability to automate their aspect of the system, but the networking part of it wasn't really part of what they were thinking about. And that's quite typical across many organizations. Broadly speaking, the network engineering and operation teams are focused on providing a stable, performant, and reliable platform. And for most intents and purposes, what people expect of a network is that it's there and that it functions, and you don't really have to think about it. Actually achieving that is hard, and that's why network engineering as a discipline is a very difficult thing to master. And there's an extent to which that's perfectly okay. If your network is performant and reliable and available, and you never have to think about it, then clearly your networking colleagues have achieved their goal, and everybody ought to be happy. But it's no longer sufficient. The world is changing, and our ability to roll out infrastructure, especially in a virtualized environment, requires us to think about the ability to roll out network infrastructure, especially virtualized network infrastructure, in the same way and using the same tools and capabilities as we're already used to in the IT services space. And that really also means, therefore, that the same kind of conversations that we've been through in bringing together dev and ops in the IT services space will have to be extended to people in the networking space too. You need to be able to bring everybody in the IT services stack together in one team. And that clearly requires conversations that today people don't appear to be having. So that cultural change is something that people need to think about. Because if you're not talking to people already, it's going to be very difficult to bring them into your world of automation.
Great, thanks. Can you talk to me, maybe the whole panel, what's driving the need for networking automation? Is it the applications? Is it something else?
Sure, I'll take a stab at that one. There's various things, and I think from a technical perspective, I'll focus there because the culture I definitely agree with. But technically, you can look at what other teams are doing within IT today. For example, if it's application automation, with tools like Ansible, it can be, again, Puppet Chef, SoulCycle, whatever it is. Those exist and they're around. They're doing a great job. And in the network space, I gave a talk on Tuesday night locally in the city here. A network engineer's templating system today or deployment system really exists around Notepad, right? You literally write commands in Notepad file, and it might be IP address, should be x.y. Again, x is a site ID. Y is your device, 4th octet, right? And these things aren't scalable at the pace of which business is moving today. So I think that's one part of it is looking at automation, again, focus on the lower levels is standing up new kits. That's one part of it. It just doesn't scale with how easy it is to deploy new infrastructure on the application side of things. And I'm a huge advocate of looking at automation, for example. I'll repeat this over and over again, but day 2 operations. How do you try to get, and I'll say Facebook-ish, how do you try to get automated diagnostics and automated troubleshooting to that certain extent where networking hasn't changed all that much in 20 years. So some of the troubleshooting aspect could be automated, and again, when issues arise, a lot of times it's because it's a multi device system with load balancers, firewalls, and switches. It's hard to troubleshoot that kind of system, and these things are becoming coming to the forefront because of platforms like Ansible, even things like vCenter that exist today in the server world. You can literally right-click a VM, clone it, have it back up. And on the network side of things, devices are still managed one at a time, at least for the past 15, 20 years.
Yep.
I use the quote, if you can't do it with brains, you can't do it with time. In other words, networks are getting larger, scaling out, and you need to be able to automate it to do it with brains, to do it with tools like Ansible, because you just can't type fast enough to be able to do this and do it accurately. So just the scale of networks is pushing automation.
No, I agree, and scale doesn't always impact every environment, but the predictability and reliability of automating a task is massive versus trying to have a change control window open, which is very common, and then going in to type it manually, right? You can fat finger something, right? Even if it's in a GUI or a CLI, and so automation at least, it takes that away from it, making it more predictable as well.
Yep. Great.
Yeah, I mean, we see this at Cumulus where, just as Nathan was saying, when everyone has a seat at the table, when you have a business that, a CTO who says, I want my infrastructure team to be one, the person who manages the app infrastructure, the server infrastructure, and network infrastructure are in one team and talking together. Those sort of teams want to use automation. So, so you get companies come in and they say, hey, we really like your product. We want to build your network using your product, but can we automate it? Because the server guys and the app guys use it, and we want to have a unified maintenance policy. So, some sort of uniformity about our tools. We want to have the same type of monitoring tool, the same type of deployment tool, and maybe even the same type of deployment strategies. So, for example, if a server goes bad, you just take it out, put a new one, run your Ansible playbook, and it's up and running. We want the same thing for the network as well. So, a lot of businesses, who ask about network automation are businesses who are reworking their infrastructure teams so that you have these converged teams where it's just not siloed, where the storage guy is on a storage person is on their own and the server guy is on his own, but everyone is together, working together, troubleshooting problems together, deploying together, and then you get reports back to the high level management when they say, hey, listen, we need our infrastructure expanded because we'll be getting so many X number of customers hitting our website 2 months from now. We need this level of capacity, and they as a team can say, yes, we can do it. And they're way more productive and they're way more agile and save the company money.
Great. Yep. I'm curious to know from the audience, how many people have used Ansible in some way to manage networking devices, whether it's a load balancer or firewalls or switches? Okay. So,
has it been a problem for the other ones?
It could begin.
Automation in general, the networks, has it been a problem or something that an organization is trying to get over a hurdle with, because network devices don't have APIs today, so they are harder to automate. Has that been a problem for folks out there?
Yes.
Great. We can dig into that question a little later for sure. Stanley, I think you began to touch on this, but maybe do you want to expand a little bit on some of the business reasons that you've seen as why companies would begin to implement something like networking automation?
Yeah. So as business leaders think of infrastructure, the network infrastructure as just another service, and they want it to be agile and flexible, just like the rest of their infrastructure. Usually, I feel that that's what drives these companies to want to have network automation. Companies that basically don't see any value in that, at least for now, I feel are missing it, and so it's sort of our duty, in the industry, people who are really trying to preach this message, to basically show that just in the same way that automation and the practices around automation, the testing practices, the staging practices that go around automation, how they've helped the server and app industry, those same benefits can also apply to the network. And it doesn't even really have to be at scale either. It could just help just the general, just the day-to-day maintenance of your network, even if you have 30, 40 switches.
Any other business motivators you guys can think of that you want to touch on?
Well, we touched on one a moment ago, the ability to respond. How many people here have been to a pop concert recently and bought a ticket via Ticketmaster? Anybody? I have. Okay. So how many people were able to do that easily and spend less than, say, 3 minutes in the interaction? Okay. The last time I tried to buy a ticket via Ticketmaster, it took over 4 hours, failed multiple times, and wasn't a great experience. Part of the reasoning behind that, of course, is that they need to be able to build into their customer delivery systems automation that allows them to respond to scale. And this is an end-to-end capability. It's not just that they need to spin up more servers, because at that level of scale, this is an AC/DC concert where there are hundreds of thousands of people trying to buy tickets at one time. The only way that Ticketmaster could realistically scale up to being able to deliver dynamically in that period of time, from when they announce ticket availability to when they're all sold, is through some high-level automation. And that automation is not just about spinning up more VMs, it's about spinning up more network connectivity, it's about being able to shift loads from different data centers and re-establishing routing, re-establishing DHCP, re-establishing DNS within a very, very short period of time. That, at the networking level, cannot be done manually. So there are business requirements, and we see them in that example, we see them in the finance world, we see them in the ability to quickly be able to roll out branch offices, for example, where you cannot achieve the outcome the business needs unless you're going to automate it. It just can't be done. You can't do this kind of thing manually. So the world in which networking infrastructure is managed manually is not going to be able to satisfy the requirements of the business. You just can't do it that way anymore. And there's some leading businesses that realize this. So there are people on the leading edge of automation who have made this kind of thing work. But increasingly, those requirements are filtering down, and we're seeing this need in many other businesses that, well, it just can't be done manually anymore.
Yeah. Also, we've also seen, and this is mainly for folks who are outside of the U.S. There's more adoption of IPv6 outside of the U.S. and to deploy a reasonably sized IPv6 network, it's best to use automation. You don't want to be doing it manually. So that's been another driver towards network automation, is adoption of IPv6.
Okay, great.
One more point that I'll make is because a lot of the examples too around scale and burstability, aren't always relevant. Being local, I've talked to lots of customers over the past 6-7 years in New York, and a lot of them would say it's not relevant to me. But I can recall multiple times where change control window happens, it's on the weekend, change is done manual. Again, configuration was done, they were cautious with it. But then, if you look at the network that was deployed, let's say there was 3 or 4 new VLANs, and then there's associated SVIs, HSRP, all these things configured. Then it turns out 2 of the VLANs, missed the SVI for to be configured. And even if you take gradual steps to do this, you can do the change manual, but then leverage automation, right, just to validate the change is as desired, right? Totally not for scale or blasting configurations. It's basically, well, you want to gradually, take baby steps to get to automation, and just ensure that all the SVIs are configured as they should be. And even that alone, they roll back the changes right on the weekends and have to go back now the next week and take down the business. So even that is fully relevant, where things you can do that's, again, not just pushing configurations.
Sure. That's a good lead into my next question, and maybe we can get a little bit more technical here. Jason and Joel, I think, Stanley, you've had a lot of experience here too, in terms of building actual modules for Ansible for various networking devices. And I don't know much about networking. I never spent much time with it. But what I'm starting to realize is that there are kind of big conceptual differences between pushing out configurations to a server versus pushing out configurations to a networking device. And maybe that's just the traditions that people have used, or the interfaces that the vendors have supplied. Can you walk me through how? Maybe start with you, Jason. What are the fundamental differences between the way people configure networking devices versus other things, and how does that impacted your module development?
Right. You're not a networking guy, and I'll be honest, I'm not an application or or a Linux sysadmin by any means. But from a network perspective, looking at how it's been done, right? Again, it's largely been CLI, CLI driven. And I usually like to quote John Willis on some of this stuff. John, big DevOps person, and going back, he would talk, give the example of Bob scripts. And first, you didn't want to automate, then you'd write proprietary scripts, and then eventually, better tooling emerged, and now Ansible can do a lot of great things. And I think in the network industry, it's similar. It's a similar workflow right now where sysadmins were probably 5, 6, 7 years ago. So when you look at the differences, right now, things still are largely done manually. There's a lot of tools out there, and a lot of them don't natively do orchestration capabilities or have built-in conditionals, things like that. And if they do, they're usually very, very expensive to get going, and you can't just download it and have it going literally in minutes. So so as far as looking at it from perspective of developing modules, it was basically trying to target things that are repeatable and that often change. And in the network space, the example that always comes up is Vlan provisioning. This should not be hard. And if you have a data center of 5 switches, 10 switches, or even wiring closets, right, connecting phones to phones back into the data center, right. You should be able to have push button automation. So so again, I've done demos with Tower even. Click a link, Tower launches a web form, fill it out, VLAN pushed wherever you want it to go. So as far as the development itself, I think one of the important things is the idempotency. So all the modules that, for the most part, that I've written are idempotent. So if the devices are in the desired state, don't make the change. And I would say, to a large extent, a lot of tools today don't actually go out and check current state first. So it's just good we're not going to go try and potentially break something that shouldn't be changed because it's already in that final state.
Yeah. The native interfaces that you're talking to, do they tend to lend themselves well to that declarative state model, or do you have to build a lot of that yourself into the Ansible modules themselves?
Yeah, that would be different per platform itself. So every vendor has its own API type, and a lot of my recent work has been with the latest and greatest from Cisco and their APIs, running their Nexus platform, for example. And again, it's a REST-like interface. You can send a show command down an API call and get JSON and back XML back. So it's really nice. You don't have to parse through raw text. And another example is Juniper. We have folks in the back from Juniper actually, where you can you can actually, like, the OS itself is idempotent, so it's only going to merge what has to get changed. And that's really nice too. So again, it really depends on the vendor platform.
Sure, great. Joel, what's your experience been?
One of the things that attracted me to Ansible was the fact that it's agentless and you can run the agent locally. So you can do a connection local on it. So there's a lot of networking devices that that don't have Python on, or you can SSH into them, but you can't invoke a Python module. So one of the things that's coming now with what Jason talked about with APIs, with the Nexus switches, you would run those modules locally and connect through a REST API to that device. Or in the case of ACI, you would connect to the REST API of a controller to configure those devices. So as those devices are becoming more and more API friendly, it gives you the advantage regardless of what the native operating system is underneath it. You can still communicate with that, but you're going to do that differently than what you might do with a Linux server, for example.
My experience gravitated towards Ansible first as the first sort of configuration management tool to use, again because it's agentless. Building a module on Cumulus Linux is different than the experience mentioned here, because Cumulus Linux is basically just Debian with tons and tons of interfaces. So writing the module was as if I was basically building it out on a server. So it wasn't. It's actually been the easiest modules for me to build because I built others for other configuration management tools. The thing that I really liked about building the Ansible modules was the fact that you basically just need to learn Python. That was it. I didn't need to learn some other language or some other strange thing, and that process was fairly simple. And again, the thing that makes Ansible nice for network automation is the fact that it follows a task-based, a step-by-step kind of configuration, which is very important in networking. You first need to basically enable your port, before, or, well, not always. You first need to configure your layer 2 before you configure your layer 3. Or, in the case of Cumulus, you have to basically license a switch. And then after the switch is licensed, you can then configure your ports. And the fact that you have to follow those particular stages and the way that Ansible kind of enforces that is very nice and makes it much easier for networking engineers to learn automation. So, it's actually been a tool that as Cumulus Networks introduces network engineers to automation, they have tended to like what Ansible has offered because of the fact that it's kind of similar to what they were kind of doing with their notepads and everything, except now it's just faster.
Mm-hmm. On that note too, at the very least, Ansible a lot of times is used just for templating configuration files. Build the template in Jinja, store your variable files in host vars, group vars, however you're distributed internally. And again, click that go button, execute the playbook, and you can have 100 text files created, and then put them on the box manually, right? I wouldn't recommend it, but that in itself, just using the template module in core is a phenomenal first step, in network automation.
Yeah, it's a baby step,
Yep.
but it's a step forward. Great. Nathan, the ideas of continuous delivery and continuous integration are really, they're the standard in any modern application development pipeline. How does networking automation play into that? Are there tricks and traps?
Well, that's a very good question. So first of all, in the traditional physical networking world, if you want to do any kind of testing or development or automation against networking kit, well, you need a piece of networking kit, and that's expensive. And you need sufficient networking kit to actually look like the production environment to be able to test anything successfully before you deploy it into production. And that's really expensive. So fundamentally, you're stuck with the key idea behind CI/CD is being able to do testing in a clone of your production environment. But when your production environment has to be a physical network and you need a clone of that, you're kind of stuck. So the first thing you need to think about is how can you virtualize your networking infrastructure so you actually have something to test against before you start deploying stuff into your production. And there are two aspects to that. One is what's called network function virtualization, which is the idea network functions are just becoming VMs. As an extension of that, we have tooling in Cisco called Viral, which allows you to build virtual networks. That's the key thing. Once you're able to build a virtual clone of your networking environment, you put yourself in a position where you can start to do continuous integration, automated testing, and then continuous deployment. But that's the first key part, is that virtualization. Once you have that, and we're starting to have that now, it starts to become possible.
Yeah, I think that this is something that all the networking vendors have embraced. The fact that in order to really speak to this automation story, we need a way to be able to test it and begin to behave like the server and app folks, where you basically go through a testing, staging, and deployment cycle, because that's just the way automation works. Right. So.
Right.
Yeah, and this is the part that excites me the most. I was talking to Spirent, which is a company who sells packet generators, right, for just testing throughput of devices. And they even have a Jenkins plugin. And when you start thinking about a lot of this, right, even on the physical side of things, you can literally, spin up a test network or again, if it's a large organization, physical network equipment, and then literally deploy a change configuration, then test, a certain traffic type across the network, just to ensure it's going to get through the network, because maybe your firewall policy change is going to block a certain traffic type. So there literally are so many things that can be done, once we get past this initial hurdle of just understanding what automation can do for the network side of things.
Mm-hmm. Great.
And that idea is something that we're also developing as a service in the DevNet part of Cisco. So we work with a company called Qualysys, who again are building plugins into Jenkins. So there's lots of people thinking about the idea of how do we take what we've been doing in testing that we understand in the application world, how can we integrate that with the standard tools and bring in network infrastructure? And actually just providing a lab as a service is one part of that, virtualizing that is part of it. But the key thing is that we know how to do this in the development world, in the apps world, and practically all of that applies over here. We've just got to rethink some of the concepts slightly. But all the tooling, all of the ideas, and everything we've done there can apply over here. And we do have that working in many instances. It's not generally adopted, but it's certainly been proven out, and we've seen how it can work.
Yep, great. Joel, some of the work that you've been doing with the Cisco ACI stack, I know you've done some prototyping, some modules, some playbooks. If the audience were to want to try some of that stuff out in their own environment, what would be the first steps that you would suggest they take?
Well, I mean, writing modules to ACI, and I don't know how many people are familiar with Cisco's application-centric infrastructure. You've probably heard of it because it's certainly big a lot in the press. I mean, one of the challenges there is the simulator piece that Nathan talked about, and there is a simulator coming for that. I'm fortunate to have a number of real fabrics to work with, and not everybody's able to do that. Mm-hmm. But I mean, it was relatively easy to write modules to interact with that. I mean, I had some experience with, and some of the work that Jason's done helped me out a lot in terms of learning how to interact with Ansible in a network world and running connections local. And had done a lot of work with some Python code to be able to sync data centers up, sync ACI fabrics up. So it was a pretty easy transition to be able to take that skill set and understanding the ACI fabric and Ansible and put those together. I started to work on the module for ACI on a Friday afternoon, and by Wednesday I had a YouTube video explaining how I did it and what I did with it. So it's really not that hard to do. And I'm kind of curious about how many people here have written an Ansible module. What, show of hands? Okay. So relatively small number of people, but it's not that hard to do, and I would encourage you to try to endeavor to do that, because you certainly will come into, I think, a use case in the if you're dealing with networks, you'll come into a use case where you want to do something specific, where having have a module to do that would be very important to you. Where we're going with our ACI deployments is the fact that there's a GUI on ACI, but even with that GUI, it doesn't provide the degree of automation that you need. It's very much plug and play to bring a fabric up, but the network engineer still has to configure a lot of tasks. And what we found with our initial deployments is that they can't type fast enough to do that. So really what I'm trying to develop within our organization is a practice for development engineers or implementation engineers, so that they'll create a series of XML files. They'll use ACI modules that I've written to be able to build up deployments for their customers. So it really comes down to the fact that they won't need to write those modules, but having that methodology of where they take the different steps, as Stanley was talking about, to be able to do a deployment and to be able to put those together in a playbook and then run that to be able to instantiate that in their customer environment, I think is going to be very important for their success.
Mm-hmm. Great. So what's missing? What's missing from the world of networking automation? Where are the weak spots? Is it is it on the networking vendor interface side? Is it the applications, or is it in the heads of the networking engineers that you're working with?
I'll
Nathan,
take that last
you can tackle.
It's trust.
Okay.
Network engineers like the fact that they can configure networks with CLI because of the way they're trained, and therefore the way in which they express their understanding of networking, and therefore when you're trained a certain way, you can express yourself a certain way, and you use CLI to configure the network, you understand that. You trust it. If you have to debug it, you know what's going on. As soon as a piece of automation comes along, and it's a black box, and you don't know what's going on, then you don't trust it, but you're held personally responsible. But you didn't develop that thing, somebody else did, and you don't know what it does. But if things go wrong, you're responsible. So we've seen many deployments of network automation systems where people will roll out very fancy network automation, lots of GUIs, lots of really amazing features. But when things go wrong, all of that gets pushed aside, and the network engineer gets on the CLI and debugs it the way he knows how, because that is what's going to work for him when something has to be fixed immediately, and that's what he knows. And it may well be that somewhere in this body of software that's been deployed at great expense, there's something that might have done it automatically, might have done it quicker, but that's not what he trusts and knows, and he's responsible. People just revert to what they know. And getting people beyond that to get them to a level of trust where they're actually going to trust a body of software that they don't understand, they're not responsible for, and they probably can't do anything about is a tricky one. And that's a culture thing. The technology can do it, there's no question. We have technology that uses artificial systems analysis to actually debug MPLS issues, called MPLS Diagnostics Expert. And it's literally an AI system that's mirrored on what people do when they debug MPLS issues. And it's magic in action, but actually getting people to use it. And that's true of many forms of automation in the networking world. And that's a training, trust, adoption issue. So the idea you had, for example, Jason, of using automation to generate configs, which then, as a network engineer, I can read and debug and understand and then deploy, that's a good one, because it's a reasonable balance between actually making use of automation and actually doing something that automation will give you benefit from, but still leaving it in control of a network engineer who can still read that config and choose whether or not to deploy it. And that starts to build trust, and then you can work from there.
Yep.
Again, agreed. A lot of it is trust, and even going back to the troubleshooting. If there's an error, you get back onto the CLI on the box. And I even did a prototype of a module last year that dynamically troubleshot OSPF as a routing protocol on the network side. And as an example, OSPF needs things to match on multiple routers to form an adjacency. Things like MTU, hello timers, dead timers, and network type, and be on the same subnet, and all of these things. And again, you can literally have a module that goes out, queries the devices, gathers this stuff. Because if it was a larger network, let's say multiple routers in the same segment, it really would be 3 or 4 commands per router across those routers, trying to see what the issue is, right? So even it really comes down to trying to see what the best way to gain trust in a certain organization is. It might be config building, right? You can push a config into Git and then pull from, let's say, Tower from Git. That way you have that version control built in. Or it could be dynamic troubleshooting, right? And again, both of those options, you're not necessarily pushing something to to a device. So I really think it comes down to just really gradually going through what's possible in automation, versus, because I think a lot of the fear comes in, what if that one change brings it down, right?
Yep.
But until we have the proper testing infrastructure and things like that to validate it, I think it's going to be a slow-moving process before we get there.
Yeah, there's one key thing here we have to remember. If you get a server deployment wrong, that's unfortunate, but then you can fix that server. If you get the network wrong, you're buggered because you just lost connectivity and you can't do anything, because if you can't connect to the IT infrastructure, there's nothing you can do about it. So there's a lot we can say that network configuration is like doing servers, and a lot of the technologies you can deploy in server configuration, you can deploy in network configuration. But there's a key difference. The consequences of getting it wrong are fatal, because if you don't have network connectivity, nothing else is going to happen. And that really is a difference. And you can understand that introduces a level of paranoia into network engineering and operations, which is a very healthy level of paranoia to have. That's one you need to respect. If it goes wrong, there's nothing else that can happen afterwards.
Yep. So the stakes are higher, and therefore the level of trust required is higher.
That's right.
There's a skill set gap too. I developed a Python programming class geared towards network engineers on Nexus switches, because there's a Python interpreter on Cisco Nexus switches. I've done 3 of those classes now for about a dozen students, and it's really geared towards entry-level Python and just trying to do some very basic things and understand the language. I get about a 20% pass rate, and that's just people providing some simple code at the end of the class to show that they've taken what we've had in the lectures and apply that concept. So, there's that gap too, is the typical network engineer, there's probably only maybe 20 to 40% of those people have coded in the past and understand that methodology. So there's a skill set issue there as well.
Mm-hmm. Interesting. Okay.
Well, I mean, like, at Cumulus, it's basically been, we're just trying to educate network engineers on, on the benefits of using, automation. And so, like, with Cumulus Linux, because it looks a lot like a server, then it actually scares some network engineers. But once they get into it, they begin to realize, it's not so bad. One of the things that that we showed them, and some of the things that that I've used with some of our customers is using Ansible to actually troubleshoot it. Okay, so we had a customer who had I think it was an OpenStack deployment or something, and he was having some connectivity issues, and he wasn't quite sure where he knew the IP address that was affected, but he didn't know where that traffic was going through. So we actually just used the basic Ansible command and shoved it to, and we created like an inventory list, and we knew it was these particular racks. So he used some type of regex key, and we pointed some basic troubleshooting commands. So like in Linux, that's bridge FTP show, and IP neighbor, and we're able to identify the path of where this particular traffic was going through by blasting the same command across 25 switches. And he was like, oh, I didn't know you could use Ansible like this. So and so we educate people who go through our boot camps that, hey, you can now do things like this. This will make your day-to-day job easier. Just because you have an automation tool in your network, now you can be able to troubleshoot in this distributed fashion. You don't have to go box to box to box to box. Yeah. And when they see that, they get excited. They're like, oh, wow, so I can actually save time and do other things? So for us, we've been really trying to like show the positive sides and try to tear down some of that paranoia. And of course, as the networking industry makes improvements on the testing piece and on the staging piece, that will further help allay those fears. And I feel we're all rapidly getting there.
That's a really good example. Take small things. Is an IP address assigned to an interface? Basically, you've got to go and log into every router, do show interfaces, and see whether it has that IP address. Very amenable to automation. Not a challenging thing to do, but if you're doing IP address management, something that you spend a lot of your time doing, but it's a small thing, automate it. And Ansible, we've seen, is very amenable to that kind of thing. If you go through the sort of day-to-day life of what network engineers and operators are doing, a lot of it is very tedious, basic stuff, which is incredibly amenable to automation, but more to the point is practically risk-free. You're not changing config, you're just doing really basic things, which can help improve people's lives, give them a chance to think about the wider business, etc., take away the tedium, and generally improve efficiency. And if that's all you do, then you still achieve something very useful as an outcome, and you started to demonstrate the benefit of automation and the technology and the framework.
Yep. Well, that's great. I think that really mirrors the way that people pick up Ansible for other purposes too. It's not that they go in full bore and build an entire playbook to deploy their application. They use it to solve some little problem that's been causing them some pain, and then they start there with a very small use case, and they begin to identify other possibilities, and before long, this Ansible glue has spread across the entire environment. So that's great. So I want to leave some time for audience Q&A. I think we have some roving mics around, so this is a great time to pick the brain of some of the networking automation experts up here.
Any questions? Yeah. We'll start up here.
Hi. So one piece of network automation that's been around for years is Rancid, which it's meant for pulling configuration files out of devices, but it also lets you send commands the same way the examples that you folks just gave actually could have been done perfectly well with Rancid. Mm-hmm. So the question I have is, how can we get the automation philosophy that Ansible has, how can we get that onto, Rancid actually is anything with the command line can be eventually stuffed into Rancid with some pain and suffering, and perhaps writing your own custom module. But how can we get the philosophy that Ansible has, where we're not just running commands, but we're also verifying the state of something and changing the state of something? How can we get that into Ansible? That I think is the kind of transition step we need for a network engineer to start trusting the code, the automation platform.
Well, I think what you're saying, exists in a lot of the modules that we've developed. Like that's sort of the approach that we're taking, and we're doing it sort of, I guess, without that pain, right? In terms of trying to do something that was developed in Perl or whatever it was, 15, 20 years ago, is that we're trying to, refocus at least now, right, on modern devices with better APIs. But I agree in conversations all the time now. It's what about the other 90% of our devices that have been there for the past 15 years? How do we automate those? And you're right. Some exist today, but modules could be developed that leverage SNMP to the device. It could be SSH, Telnet, whatever it is. And if Rancid gets you there, that's again, whatever's used within the module itself, it'll work, right? And part of it is within Ansible to try to at least maintain the framework of idempotency, where you are doing some intelligence within the module to check state before a change is made, versus in the past it was just push. But there's no reason why more modules can't be developed that leverage, again, Telnet, SSH, SNMP as the mechanism to communicate it. In fact, a lot of times, it's, if you have a multi-vendor environment, if it's Cisco, Arista, Cumulus, Juniper, what have you, it's a different module per device type because it's different APIs in the backends. So one question is, well, how can you streamline that? And so now a few of us are trying to figure out, well, does it make sense to build a community-driven inventory module with SNMP, because the MIBs should be the same to identify the ID of the device or what have you. And based on that, then you at least know what modules to be calling. So in your conditional, it's call this module when ID is Cumulus or when it's Cisco. So and that would probably be written for legacy and modern, leveraging MIBs, because MIBs are supported everywhere. But it comes down to the effort. And I think again with API-driven devices, like the effort to write the modules, or it's more streamlined than trying to go back and do screen scraping and things like that.
There's one other aspect to your question. You're pointing out that we've had a technology for a while that would have allowed us to do this, and that's true of many other technologies. So it's not as if the notion of being able to automate networking interactions is new. It's the demand for doing so that's new. You kind of have to do this, and that's coincided with the DevOps movement and with the rise of frameworks like Ansible, and with the fact that they've demonstrated, at least in part of the IT infrastructure space, this stuff is perfectly possible. Let's not forget that 5 years ago, people configured servers manually too. So everything we're talking about that people are doing in the networking space is exactly what people did on Linux and Unix servers 5 years ago. That was all manual as well, and that eventually became automated. So there are many things happening here. The possibility of technical capability of doing this is not a new thing, but it's multiple ideas coinciding, and virtualization is also an important part of that.
Yep, great, thanks. I think we had a question over there.
To the point of, if the network goes down, that's it, there's nothing you can do after that to reach it or fix it. Is there any pragmatic solutions or architectures you guys have seen outside of kind of API-driven devices, because still if they're not able to listen on an external network that you were configuring them on, kind of rolling back to a safe state, or maybe having an internal, centralized, whether it's Ansible or something else, node that pings them, and if it's there's no receptivity to the outside world, I'll reset it back on an internal management network or anything like that?
Definitely. A few things to think about there. First of all, you're typically connecting to a device via management IP address. So whenever you write your code that does anything with interfaces, always write a check in there that says, is this a management interface? And if it is, don't touch it.
Exactly.
If you do anything to your management interface, then you don't have any management connectivity. The other thing is that in certain operating systems like iOS XR, you have a rollback capability. And broadly speaking, you can do configs that will only be committed after a certain period of time. So there are things that are built into the operating system, both in XR and we heard also in Juniper too, and the programming tips and techniques about what you do and don't change when you're interacting with devices.
And so also with the network design, so with the white box switching movement, basically instead of just having your server connected to one box, you now have it connected to multiple boxes. So if you make a mistake with one box, it's okay. Your server still has another connection. So like a leaf spine topology, you basically set that up with many switches. And of course, since you have many switches, you need to automate. So if you do make one mistake, small mistake somewhere, it's not so bad, because at least you still have server connectivity, through another path.
One more point too is, when you're making a change, right, the module's returning data back to Ansible, and send other modules that I wrote, the best. So in terms of, this example, I returned back, what the state was, and what the proposed state was, existing state, and what the state is after the change. So you can register those objects and check to make sure it is what you want it to be, right? And if not, then you can actually execute, something else to either try to, do a manual rollback and push another command or something. But you can still register the data coming back because that should give you a good idea of if it took or not. Yeah.
That's a very standard programming technique, the idea of checking preconditions and postconditions. That's a standard pattern. So have you actually got what you thought afterwards? And if not, you can do a rollback.
Yep.
Greg, I think we had a question in the middle of the audience right there. There we go. Good.
Mine wasn't so much of a question, but I wanted to share my experience. I was tasked with writing some Ansible modules for two types of HP switches. One was a H3C, ComWare-based, and one was Provision, neither of which had a REST API. So the way I approached it was, I wasn't a network guy going into it. I'm good at sysadmin, I'm good at DBA and that sort of thing. So I had never used these before. So I got the manuals, figured out how to do some basic things. I picked one thing, add a VLAN, delete a VLAN. And I realized that one of the toughest things that I had to figure out was how was I going to do this? And I had to figure out how to connect to it. So I thought this is going to have to run locally, just like when I was wrote the Docker fax module. I have to run it locally and I have to connect to the switch. Then I have to figure out how I'm going to send commands, deal with space bars, disable paging, set the terminal type so I don't get a bunch of junk characters. So I found that I was doing a lot of the same things. So what I ended up doing was writing a module that was for talking to HP switches and subclassing based off of the type of output I have from either one. And then I realized there were some basic functions in each one of those types of switches that I could do. Dealing with interfaces, with VLANs, with users, and building it out from there. But it's really tricky when you have a switch that doesn't even have REST, that you have to talk to it like that. Some of the, I think more modern HP switches, they're starting to put Python interpreters and also possibly some sort of POSIX environment, because you can't just do a Ansible ping, because Ansible ping goes in there and creates a directory structure and does what it has to do. But in answer to your question about gathering information in files, the way I approached that, the first thing, before I did anything to create VLANs or anything like that, I said, gather facts. I want facts. Facts are great because once you have facts, you can do all kinds of neat things. So that's the one Ansible way of approaching things is you gather facts from the target that you're managing, and that's how I did it in that case. Anyway, that wasn't a question so much. I just wanted to share that because I hear a lot of the same things that I went through when I was doing mine.
No, that's great. Thank you. I think that comes back to, where are the weak points? Are you dealing with legacy ideas like page breaks and new lines and so on, or is it a real modern interface? Todd, I know we're past 4 o'clock. Do we have time for one or two more questions, or should we wrap up?
A couple more questions, if you guys want.
Hi there.
Check.
Hi, Will Dennis, NEC Laboratories America. One of the biggest things that I see with network folk using automation is there's a complete lack of a way to test it, and kind of do test-driven development. Mm-hmm. Do any of you guys have any suggestions? I mean, some friends of mine have gotten certain things working in Vagrant, where you can Vagrant up something and test the automation against it and see what you get, but it'll never be common because just the way vendors work. But do you have any ideas around that, how you might achieve that?
One of the first things I'll bring your attention to is something called VIRL, Virtual Internet Routing Laboratory, virl.cisco.com. It's a toolkit for developing virtual networks. It's built around OpenStack. It has an Eclipse-based UI. Very trivial to use. You click drag and drop and create topologies. It auto-generates configuration for you. And most importantly, what it's running is called a virtual reference platform, and that's literally a VM version of the same software that goes onto a switch or router. So it behaves in the same way for most intents and purposes. It'll route traffic, it has some layer 2 features, it has all the same management capabilities. So that's network virtualization. So once you can virtualize the network, you can create multiple different kinds of virtual copies of your network, then you can start getting test-driven development. But that's the key missing piece, and that's a relatively recent arrival. And it is a game changer, being able to virtualize your network.
So some of your modules, you're doing the same functionality against 100 switches that are the same type. So depending on what you're doing, you can test with one switch and roll that out into multiple ones. If they're all the same, if they're all the same version, and that's your use case as well. So you may only need one real switch to do a lot of your work.
Yeah, the virtual side too, it depends on device type, right? Cisco has the CSR 1000V virtual router. Juniper has a virtual firewall. There's VEOS from Arista. So there's bits and pieces of this that exists. It's a matter of unfortunately, does that match what's in your production environment? It might not match, and that's the key. Is to drive, honestly, it's just to drive your account teams right from those vendors trying to get something, even if it's beta from the vendor.
One more question?
Oh, sure. So I'm a systems guy. My company might one day use HP servers, and the next day they might use Dell, depending on what kind of deal we can get. We use Cisco top of rack with Juniper on the backbone. One of the frustrating things is there's no POSIX type of standards. So I might have obviously there are things like BGP or OSPF, but it's very difficult to write one command that I can run on all of my switches to get data, for instance. Is there anything in the horizon? I know that obviously there's been huge competition between all of the large network vendors, not necessarily a lot of cooperation. With the needs of businesses today, will that change, do you think? And maybe it's outside the scope of this discussion, but that's certainly something that would maybe empower people outside of just the network community to help.
You're asking if OpenStack will help you. Is that what you mentioned, Horizon?
No,
on the Horizon?
Standardization across
across all different vendors.
Yeah, okay.
I wouldn't mind taking. I'll go first, actually.
Oh, okay.
But so I'm pragmatic. I would say there's never going to be a uniform API. It's just not going to happen. What's in it for the vendors to? Again, we have one up here, but what's in it for them to deploy it, right? There's some things coming from the community, right, out in the valley, but I wouldn't count on it. So I actually view Ansible as the unified API, right? Let's say Tower was deployed, then you can make an API call to create VLAN, and that playbook has a lot of conditionals, right, to check to see device type and so forth. But if you didn't have that, then the playbook can still exist. And at that point, we just need, let's say, a VLAN module for whatever vendors you have deployed. So that would be maybe a happy medium.
So Ansible gives you a layer of abstraction.
Yeah.
Think of it that way. Ansible is a layer of abstraction for network devices. You may have to have different modules to communicate with different devices, but your task of what you're doing, you're trying to do that on those different devices. So there is some value to that level of abstraction that Ansible provides for you.
So are you saying that it's sort of similar to Yum, apt, and emerge?
Yeah. That's it.
Yeah.
Okay, well, there is in fact standardization coming for networking interfaces. In the IETF, there are two main bodies of work to think about. One is called netconf, which is an SSH-based management protocol that effectively establishes a management session over SSH. What you're getting with netconf is the ability to exchange configuration payloads. And those configuration payloads are being modeled in a language called Yang, Y-A-N-G. So what we're seeing in the IETF is the emerging consensus around what the Yang model for a given networking feature will be. And then when you combine Yang with netconf, you get a standard definition of what it is you're managing and a standard way of connecting to a network device. And then expanding from that, you also have something called REST-comp, which is essentially mapping the Yang models to a REST API. Now this is emerging work, and we've got some netcomp support on Nexus, we've got some netcomp with Yang on the XR models, but you'll be seeing a lot more focus around the netcomp and Yang emerging APIs and the ability to use RESTComp with that. And if you look at the Open Daylight project, you'll see an example of what we call an SDN controller that actually uses that technology. This is emerging, and one of the key things to think about here is that it gives you a lot of the commonality you're after, but you won't necessarily, even so, get the same modeled feature across multiple different vendors, because different vendors have different capabilities and therefore different ways of expressing those. But you will at least get common technologies, which is clearly moving a lot closer than we are now.
Yep. Great conversation. Thanks for all your questions, and please thank the panel. Thank you, Jason.